Hey YouTube, and anyone who may be watching. So, I've been thinking about what I wanted to do for the next video for a while now. I thought about like making one about the multiverse, about things that are unreachable for us, similar to the deism idea. But I landed on something that I think I'd prefer to talk about a lot more, especially given a recent epiphany that I had about it. And that would be black holes. I should say right out of the gate, I probably should have said this earlier in other videos, but I am not by no means a scientist or expert in anything scientific that I might talk about. I am merely a science aficionado, I guess. I'm very much intrigued by anything having to do with astrophysics and science in general, specifically physics and chemistry. But black holes are one of the things that most fascinate me in science at the moment. And I recently sort of rediscovered the epiphany I had about Stephen Hawking's idea concerning Hawking radiation and how black holes can evaporate. And it took me a while to understand how his theory works, even at like a base level understanding, because the way I understood it is that you have these particle-antiparticle pairs that are created spontaneously due to the energy of the black hole, and, the gravitational energy that it's creating due to its immense mass and small size. And so it's creating all of these virtual particles around itself due to its own gravitational energy that's constantly being generated around it. And these particle-antiparticle pairs, because of how they work, will always separate from one another because of their different charges. And so one will be pulled back into the black hole, the other one will flow out into space. And what didn't make sense to me at first about it is that I didn't get how the black hole could be losing mass if it's reabsorbing one of the particles. But then it hit me, and I felt like kind of an idiot for not understanding it. It's only pulling back in one of the two pairs, one of the two particles in the particle-antiparticle pair. So it's losing. This is how I rationalize it. It's losing that particle's equivalent in energy, that particle's mass equivalent in energy, because the total energy that's required to make the two particles is double that of just one of the particles in the particle-antiparticle pair. So it's losing half of the total mass created in that sort of spontaneous particle-antiparticle pairing that comes out of the gravitational energy around the black hole. And so in that way, because it's losing, it's essentially kind of a workaround to how a black hole can lose mass due to its own gravitational energy sort of radiating outwards. And it took me forever to realize it's essentially just a 1 + 1 problem that I couldn't wrap my head around because of the advanced physics involved. And it makes sense to me too now why this process would take so long, because you're essentially talking about like tiny, like atoms, maybe even subatomic particles that are coming into existence together, separating due to the black hole's pull, and due to their own sort of nature of being antiparticle and particle pairs that necessarily repel each other. All of those things together slowly but surely cause the black hole to evaporate. And the reason why the other particle can escape is because it's outside of the event horizon and is still within a realm in which it can escape from the black hole. Because once you cross the event horizon, not even light can escape. So there's no way for the particle to really escape if it was happening within the event horizon. But because this is happening outside of the event horizon, there's a possibility for it to escape and therefore steal energy in the form of mass from the black hole, thereby causing it slowly but surely over Google years to eventually evaporate. Took me while to understand that. And when I finally did, it was like eureka moment in my head. And I'm only understanding the very basics of Stephen Hawking's theory on Hawking radiation. Um, it should be said, Stephen Hawking is one of my biggest idols. I have very few idols, and Stephen Hawking is definitely among them. Um, or a person I would call an idol or a hero. I mean, considering his life story and the amazing contributions that he made to the world of science, definitely a hero for me. But so all of that about Hawking radiation to sort of lead into what should have been the intro for this video. Black holes, to me, they're another kind of, I guess, void, if you want to talk about it in terms of my void series and, like, just infinite nothingness. But then a black hole, which is essentially a true void in space, void of even light because of its own nature, it's a complete mystery to us. One of the last remaining big mysteries in science, which makes it endlessly intriguing. I still have to catch up on what happened with the black hole image and the sort of new information they discovered about the accretion disk. I'm not up on that, so I need to double check what exactly they found that adds to the information that image gave us in terms of knowledge of black holes and how they are shaped and function. Anyways, I kind of doubt that, how do I say it? Like, amongst what I've noticed among scientists is that there is sort of a repulsion towards anything that requires sort of invoking infinity, which a singularity would have to do, because it would have infinite density. And so I would always wonder what the true interior of a black hole really looks like if it's not a singularity. And I've heard theories where it could essentially be maybe a hyper compact star that is just shrouded behind the event horizon because its gravitation has become so high that no light can escape, but there's still an object there. But it's strange because if its gravity is such that even light cannot escape it, then that has to sort of make you wonder what happens to the rest of the matter that's there. Like, how, if light can't escape the gravitation of this region of space, then how would matter act under those circumstances? Like, would it really just be a firewall that you cross once you cross the event horizon, but then you have all of this infalling light, which compacts the potential object there further? For me, it's like a huge mystery as to how it really works. But anyways, there's also for me the really like astounding idea of being in a black hole and looking backwards and essentially seeing the entire history of the universe pass before your eyes because of the time dilation that happens and because of all of the infalling light. I mean, it would probably be impossible to turn your head in like a stellar mass black hole because you'd already be spaghettified on the way in. I don't know if maybe it would be possible in a supermassive black hole like Sagittarius A star. Maybe it would be possible to look back and sort of see the infalling light. Or how exactly would that look? Would you essentially just see the image of the universe, but it would be blue shifted more and more the further you went into the black hole until you just saw, I don't even know. If they blue shifted enough, eventually it just becomes invisible radiation. So I guess at some point you would see the universe blue shift, fast forward, disappear. So either way you look at it, whether you're looking in or out of a black hole, I guess you would essentially see a void if I'm thinking about it in the correct way. But anyways, and then there's also like this idea that the singularity at the center of a black hole, if it really does exist at the center of a black hole, might be the very same singularity that existed at the beginning of the universe, if we're considering that all mass and energy and everything that is the universe was contained within a space smaller than that of a subatomic particle. Then it would essentially mirror the conditions within a black hole, making the center of a black hole probably the closest thing we have to a sort of test subject for the early universe at, you know, the very point in which it even began to exist. So, and it's also like they've also been described as potential solutions to the dark matter problem, maybe even the dark energy problem, but it's a contentious idea and it's probably going to get thrown out because, while it would be a nice way to sort of sew the mystery up about dark energy or dark matter, it's probably not the case. And I remember I was watching a video on PBS Spacetime where they also went into that idea and how it's essentially, how do I say it? The idea isn't necessarily practical once you start considering what that many black holes would do to the universe. But anyways, I just freaking love black holes. It's one of my favorite ideas in all of astronomy and astrophysics because they're such a mystery. And they're so fascinating. I mean, they're the same objects that, on top of everything else I've described, are thought to that maybe they could be the gateways to other universes, parallel universes, antimatter universes, whatever you can think of could possibly be on the other end of the Einstein-Rosen bridge, which links the black hole on one end in one universe to the white hole on the other side in another universe. A white hole, it's also itself being a potential sort of description of a Big Bang event. Black holes, they somehow contain every kind of physics you can think of within themselves and without themselves, if that makes sense. They're just endlessly fascinating to me. I guess this is kind of like a black hole appreciation video, kind of sprinkled in with my own ideas as to how they may work and how they are integral to sort of scientific discovery probably at this point, given where physics is in both the theory of general relativity along with quantum physics, and how those two can possibly be sort of bridged together in a one unifying theory of the entire universe and of all of physics, which is just mind-blowing, just as an idea, as a concept. And it's also pretty commendable that a person like Stephen Hawking essentially made this one of his primary life goals, to try to figure this out, which is a task that all of the rest of the scientific community is also taking up and tackling as best they can. And which is why the recent experiment that showed that possibly the quantum physics model, the standard model of quantum physics, they may have just discovered that there's something outside of that model, or maybe that something in the model has to be tweaked in order for it to account for this sort of strange, unexpected error in their experiment. Or not an error in the experiment, but the findings are different from what was calculated, and so it may point to there being something that maybe wasn't taken into account previously, which means that now the standard model of quantum physics has to be sort of maybe not completely reimagined or, reworked, but new ideas might need to be incorporated in order to make it more complete, which also might help to bridge the gap between quantum physics and general relativity, potentially. The more discoveries that are made, the closer that these two theories may be bridged together. And yeah, I'm really glad to be talking at least a little bit about science and astrophysics here on this channel. I've been talking a lot about philosophy because that's kind of my bread and butter. I mean, I majored in it. It's one of my majors. But I also do just endlessly love science, and black holes are probably one of my favorite all-time objects and mysteries in science. I think what I'll make my next video about because I've been thinking about doing it for a while, will probably be parallel universes and my take on it. But yeah, I'm trying to make just short videos, keep everything short and concise, and this is more of an appreciation video than anything. I might make a part 2 if I left anything out that I really think should have been mentioned here that I can't think of right now, because I'm just kind of doing this off the cuff. But yeah, thank you to anyone who watched, and I hope you're having a good day. And stay safe, stay healthy. We all need to do that right now, especially right now. And I really do hope that everyone's okay, because, you know, I empathize with anyone who might be suffering right now. It's a hard time to live through. And thank you for watching, and bye-bye.